Hi everybody, so today we're going to be talking about center of mass. Before we start, I just want to talk about some sponsors. We have Actua and Promo Science. So before we start, we want to talk about what center of mass is. So an easy definition is that it's the average position of all the parts of the system that you're looking at. So with the pictures that are there, with a circle, it would be the very center of the circle because it's symmetrical all the way around. And another good way to think about it is if you look at a number line, the middle of the number line would be the center of the object that you're looking at. So like if you have a rod, assuming this is all completely symmetrical, it'd be the center of the rod. Another cool thing about center of mass is that it can actually lie inside or outside the object depending on the shape and the proportions that are on it. So a good way to actually find the center of mass of something is something I like to call the ruler experiment. Usually it's done with a ruler, but I'm just going to use this little wooden stick here. And you can just take your hands and you just slide it like that. And you'll notice that it's kind of getting stuck on my hands sometimes until eventually they're together. And that gives you an approximation of where the center of mass is. So like I said, it's kind of in the middle. It's probably a little off-centered because there is a little metal hook on one end, but it's approximately in the middle of the rod. So all the experiments that I'm doing today are done with everyday objects, and you can try them at home. So feel free to pause the video if you think you have the stuff at home and you want to try along with me, or once the video is up and not live, feel free to pause it then too. So the first one you're going to need a pop can. I tested it with more like Coke, Pepsi brand name cans, and I found the shape of them did work better for this experiment as opposed to maybe soda water. And then you just need some water, or you need to drink some of the contents. So this is empty right now. There's nothing in it. I'm just going to pour about 80 milliliters of water in it. It's not an exact thing. This is just an amount that I found worked. But it'll work with 75 milliliters, 90 milliliters. And all you need to do is tilt it. And you can see that it's just staying on its side now. So what happened is when I added the water to the pop can, because water is a liquid and it conforms to whatever container that it's in, right now, the water is approximately across here, and it's adding enough weight to the pop can that the center of mass is positioned here. Where if I don't have the water in it, it will not balance because there's more weight on the top than there is on the bottom. Where when the water's in it, the most of the water is going to be positioned over here because of the shape of the can, so it'll stay. So the next experiment, you're going to need 2 forks, a toothpick. You're probably going to want a couple though because it's really easy to break them when you're doing this, and a cup or a glass to balance it on. Now, I already have it done here. So basically, I'm just going to move it a little closer to the camera. You'll see that I have the toothpick wedged into the forks, just like so. And I have them positioned in this specific arrangement. Now, the cool thing is, when you do this, it allows you to do this with the forks. And it's kind of hard to see, so I'm going to try to hold it up. But basically, by positioning the forks like that, you're changing where their center of mass is. So I know it is a little hard to see in the video, but their center of mass is now positioned at the end of this toothpick, which is an extension of the object. Like I can even hold the forks here with just my finger. And something created in the real world, there's something called bouncing birds, which if you'll notice, they're actually about the same shape as the forks. So you have the bird, the wings of the bird are out from its body, and it's kind of like the shape of the forks, where it's out from the toothpick, and the tip of the toothpick is its beak. So you can he'll just sit there. Okay. So I added some pictures of the forks in here because it's a really neat thing to try at home, and it's a lot easier to try if you have a picture of how they're put together. So I provided some here so you can pause the video and try to do it on your own. Okay, so that's pretty much it for the experiments. Does anybody have any questions about how to do something or anything else with center of mass or how it relates to other things? So while you guys think about some questions, I'm going to show you something else. So I just have two wooden blocks here. I'll back them up so you can see them a little better. And you'll see that I'm balancing them on one another. So clearly you can see that I have the top wooden bar approximately balanced on its center because that's where the center of mass is, roughly. But if I was to move it, no, it's not going to stay. But another neat thing, which can relate to balance and center of mass, is where you put the weight on it affects the center of mass differently. So if I was to push on the end of it, you see it's really wobbly. But if I was to push on the center of it, it takes more to make it wobble. And it's actually off center, so I'm going to fix it there. But it doesn't move. Like, I don't even know if you'd be able to see that in the video, but if you touch on the end, it's very unstable. And the same thing would happen, like, if you were to add a lot of mass here and then a bit here, it's still gonna tip over just because the way that it affects the center of mass. So we're just gonna wait a couple seconds to see if there's any questions. There is a bit of a delay in the video, so I'll wait a couple seconds to see if anybody has any questions for me. So it looks like we have a question from someone. Is this how a seesaw works? So a seesaw, it is roughly how a seesaw works. So if you have a seesaw, let's just pretend this is a seesaw. So if you had two people on it, so say you had a child and an adult on a seesaw. An adult is usually going to weigh more or have more mass than a child. So let's say this is the adult, it has more water in it, and this is the child, it has less water in it, so it has less mass. If they were both going the seesaw together, the adult, if they went on the same position in the seesaw, it's just going to tip over, and the child's going to stay in the air, and the adult is just going to be sitting on the ground. But if the adult was to move forward, they'd be able to keep the seesaw balanced, and it would be able to work and go back and forth with them pushing off of the ground. That was a very good question. Does anybody else have any questions? Again, just remember there's a delay, so if you send it right away, I might not see it for a couple seconds. Or if you want me to show you one of the experiments again so that you can try it at home, I can do that too. Okay, it doesn't look like there's any more questions. So I think that's the end of our live stream today. Just remember, we have them on Tuesday, Wednesdays, and Thursdays. So there's 2 more this week. All of them are at 10 a.m. now. So we hope to see you join us then. Thank you for watching our live stream today.